Okay, I think that we can start. Hello, everyone. Welcome to the 5th edition of Let It Swift. This time is all in English. We have a bit more international speakers this time. So you can grab a beer if you want. There's fridge open. And I think we can start.
Maybe mute your MacBook because I can hear ourselves talking.
Sorry.
The terrible echo if you speak yourself and you hear yourself afterwards, it's terrible. Just in time, Martin. Perfect. Now I can start. Welcome everybody. Thanks for coming over. It's a pleasure to be here because it's been a while since I was looking forward to this. I had conversations with two Lucases to get here. This is the first Lucas. I looked it up. Just before COVID, this was in January 2020. We were discussing there is no direct flight to Poznan. That happens to be a direct flight from Amsterdam now, so that's one of the benefits of waiting a little longer. We tried to come up with a meetup in 2020 already, and then COVID arrived. Lots of things changed. I believe Lucas even changed the company, but he's still here, so that's good. Then I got another message from another Lucas, and here we are. So super great to be here. I want to take you back. We're going to talk about generics and opaque types and existentials. And that journey for me started at a pretty pleasant event, WWDC 22. And I'm not sure about you, but if I look forward to WWDC, I always try to make my wish list, right? So if I go back to one of the other WWDCs, Swift 4 with Codable, that was quite a big change, right? You had all those kind of dependencies that you could get rid of. Then we had the boolean.toggle, wasn't that great? I'm mostly naming it because Chris Eidhoff is Dutch and he did a proposal for it, so Dutch roots. Then we had opaque return types. We're going to discuss that today as well. Resources for Swift Package Manager, which was kind of like the last missing piece for us to really embrace Swift Package Manager at WeTransfer. And then finally, async await, long-awaited improvements in Swift. Wasn't that great? And then we had WWDC 2022, and I was like, we got everything. What do we need? I wasn't really sure what to expect, and I was planning to do a talk on something specific to WWDC, so I had to come up with a topic. So I started looking at the Swift 5.7 related proposals. This is a list of everything that was included there. I think if you look at the sessions, you had regex builders and distributed actors, quite a lot of different topics. Nothing really stood out for me yet. And then I looked at the Swift-specific sessions. We had Embrace Swift Generics and Design Protocol Interfaces in Swift. And that second one was interesting to me because I was like, we could have had that in 2015 already, isn't it? Like, when protocol-oriented or programming was the thing. And we'll get back to that later. But these are the proposals specifically related to those WWDC sessions. And when I started looking into it a bit more in depth, they started to become a pattern. We have opaque types, existentials, associated types. And suddenly I realized this must be like one of the bigger changes that we received this year. Now, Swift is open source, and that means that you can also see what has changed in every version. And this is a PR. Only 2 files changed, and in those files, nothing much changed. But the list of bugs that got fixed with this. Those are all links to radars, also known as feedback assistant issues that you submit. But quite a lot of things related to generics were improved. And altogether, we could sum up that this year is pretty much about, protocols, opaque types, existentials, and generics. So my journey started for my talk. And this is a generics proposal from a few years back the generics manifesto that was used in the roadmap towards Swift 3. And one thing that stood out was removing unnecessary restrictions. And this became a pattern along the way. Ben Cohen, John Sundell, I think you all know who John Sundell is. We're in Poland. I believe he's living somewhere nearby. But Ben Cohen was in that podcast and he said, make generics work naturally, the way people expect it to work, without unnecessary restrictions, you could say. So let's go back. And I mentioned it earlier, protocol-oriented programming. Who recognizes this guy? By any chance? This was quite a thing in 2015 at WWDC, because this was, I think, the most hyped talk from that year. Protocol-oriented programming was the next big thing, and everybody started to do that, use protocols everywhere. But in that year, there were some improvements to Swift. And I want to take you through that improvement with this protocol where we have a content with an ID, a URL, and a method make favorite. So what was the case in Swift 1.2? Who wrote for Swift 1.2? Yeah, see a few hands. No incremental builds. Perfect times. Terrible. Either way, so we have an image content and a video content, and they both conform to the protocol content. But at that moment, we had to implement the make favorite method individually in each instance. So we couldn't write a protocol extension as we do today. And that was exactly what was introduced in Swift 2. Protocol extensions allowed us to reuse logic for all the types that conform to a certain protocol. And to me, this was already an example of removing unnecessary restrictions. So it's almost like a red line in the improvements we see in Swift. This is another quote I took from a WWDC session, and this is saying Swift's goal is to make your life as a developer easier, and define easier, right? I'm not sure about you, but if I look at all these keywords, does this make it in any way easier? We have so many different types and things to think about, and it makes it pretty hard to all understand, especially if you just got started with Swift, but maybe as well if you're a bit more experienced. So hopefully today I can make it a bit more clear for you. But one thing I want to embrace here is that, don't think you should actually know everything I'm going to say today, but see it more as an introduction to what Swift offers. And if you really want to dive more deep into these things, you can do that on your own pace, at your own time. Generics are just a tool that you can use, but you can also just reuse code and copy-paste everything in a way, in theory, right? So it's just an extra tool in your tool set. So let's dive in. And I want to start with the basics. Generics basics, it's still pretty advanced, but here we have an int stack, which basically contains all kinds of integers. We can push and we can pop, and we have like a backing store items. We can make this generic, which basically means that you have a generic stack, which can contain any kinds of elements. And if we look at arrays in Swift, it's basically already what we do today. Because what you see here is an array of strings, or a stack of strings. And by reusing the logic of the array, we can also make an array of integers. And we reuse the underlying logic, because the code is generic. We also have generic methods. Here's an example where we find the index of a certain element, and we can compare the value to the value to find. And that's possible because we have a generic constraint. We say this method is only applicable if all the elements conform to equatable, allowing us to compare. You can also create an extension on an array to write the same kind of method, which will look as follows. And if you actually want to use that code, it looks like this. So we have the first global method, then we have the method on the array, and actually this is something available in Swift today in the standard library, making use of generic code as well. The Swift standard library is full of generic code, which obviously makes sense because you don't want to rewrite everything for integers or for strings or for floats and so on. So this code could be rewritten as well. to use with strings, and we make use of the same generic code. So that's a short introduction to generics. But how about opaque types? Wolf thinks he's not using opaque types today. Yeah, it's always hard to say no, because you probably realize that you will use it. Yeah, so opaque types are actually something you use in SwiftUI. Here we have the sum view, which is basically saying it's some kind of view that will be returned. But there is an essential part in this, which is related to performance, and it comes down to that the compiler kind of knows by using an opaque type what type it will eventually be, and it can predict the required memory, and with that perform optimizations along the way. So here you could say that if you use a VStack, the compiler knows it will be a VStack, so I need to prepare for a VStack, or it could be a text element or any element that you define. And I used opaque types in SwiftUI this way because we're required, but I wasn't really often using it myself in other kinds of methods. And that was an interesting learning for me along this way with this talk. But you can actually use it in different places as well. So an important point is that the opaque type requires you to have a fixed value inside the scope of where you use it. So in this example, we have two options, and it will actually not compile, because in the first if statement we return a text, but in the else we return a VStack. So in the scope of this method, the return value is not the same. If you look into what is actually returned, the VStack contains like all kinds of like subtypes as well. And we can solve this, maybe, just place a VStack around it, right? We now have a consistent VStack type to be returned. But the downside here is that in case somebody is pro, we could have returned just a text type. And now suddenly we have that extra layer around it while it's not really needed. So one thing you could do here to solve it is using a view builder. And that way you optimize this code accordingly and you can still make use of a sum view. View builder is a result builder. If you're new to that, I've got an article on that. You can look that up. It's pretty fun what you can do with it. There's all kinds of other solutions you can write with it. So opaque types, how do they relate to generics? And for that, I want to take you through like a real case scenario. This is the WeTransfer application I'm developing in my day-to-day job. We have all kinds of content. So you have videos, PDFs, images, you name it. And in this journey, I kind of want to imagine that we want to allow users to favorite content. So we start with the protocol again. We have an image content with an ID, which in this case is just a unique identifier, and we have a URL. And we create a favorite image content store. So this is very generic, or not generic, I must say, because it's fully related to images. And we allow with two methods to check whether something is favorited or to add something to the favorites. And the method to actually do that looks as follows, where we add like a collection of content that we actually want to make favorite. So this all works fine, right? We have image content. It's all suited for image content. And this is also an example where you are perfectly fine without any generics. But as showed earlier, we have all kinds of content. So we also have video content. But if I start using that, the compiler isn't happy because we expect image content. So we want to make this more generic. We have two types in this case, an image content and video content. I'm ignoring all the other types of content for now. And we can bring them together by introducing a protocol content. Both types conform to it, and we can rewrite our code accordingly. We have those two methods. We change it to content, and in Swift 5.6, this was perfectly fine. The compiler is happy, and now we can also favorite video content because the types are joined together by the protocol content. Now, there are differences in Swift 5.6 and 5.7, and I want to introduce to you an error that you've seen. I'm pretty sure you've seen that before. So say we actually want to benefit from the identifiable protocol. So we add the conformance, and we basically say that the associated type ID always conforms to UUID. And this way, we don't have to provide that ID property anymore, but we can benefit from the identifiable protocol. If we now go back to this code, who has seen this error before? You know, to me, this was like a perfect example of unnecessary restrictions. You know, you write your code, you're like, this should work, it makes sense, right? And then this error shows up, and you're like, okay, I'll go back to the protocol, I referred it, I'll just use the property ID and, you know, whatever. But the good thing is that we can make this actually work in Swift 5.7. And for those that are a bit more experienced, they may realize you can actually make this work in Swift 5.6 as well, using generics. This works. You have T conforming to content to a protocol. We can also write it using the where clause as shown here. But what is new now is that you can use opaque parameter types. And you can write it like this. The interesting part here to me is if you're used to generics and you've written Swift for a few years, it might be harder to wrap your head around this change because you're used to writing generics in the old way. But if you're getting started with Swift, this reads much nicer. If we compare it to the old way, you know, there's way less clutter. What does T even mean? I guess type, but you know, like you could also use all kinds of other names, and then you suddenly have like a type alias, while it's not really a type. I don't know. Just using some content makes much more sense. And altogether, you could basically say some protocol stands as a shorthand for T, where T conforms to protocol. There's an important one, because if T is also used in a return value or something, there's a constraint between those places, and then you can't use opaque types. So while at first I thought, you know, I can go over my whole code base and remove all the generics, you'll quickly find out that it's not always possible because it's really like a shorthand for T, where T conforms to protocol if it's used in a single place. You'll understand that later on. So all we know is that there's going to be some kind of value conforming to content. So in summary, the underlying type is fixed for the scope of the value. We saw that in Swift UI, where, you know, it's either a VStack or a text. That's not possible. It needs to be one single type. If the generic is only used in one place, then we can use some type. Otherwise, it's not possible. That's why it's a shorthand. And if you ask me, it becomes easier to read if you compare it to the old way of writing generics. So we got generics, opaque types, and now I want to take you to existentials. So we slowly build up. I'll go over some practical examples in the end, where it will all come together, which will hopefully make it all click. So we have the favorite image content store, and I now want to zoom in to the favorite method, where we pass in an array of items. And in this case, we have an array of image content, but we want to make this generic as well. So we change it to content, and we see that same error again. Now we can rewrite this as well using generics, but it's not entirely what we want, and I'll show you. This works great, right? We have an array of image content, and the compiler is happy. But as soon as we change one of those types, there's no consistent type in the scope of the value anymore. So this doesn't work, and Swift can't deal with this. So you might think, let's rewrite this and use some content. But like I said, the type of the value needs to be consistent for the scope of the method. And in this case, it's not consistent. It's either image content or video content, PDF content, can be anything, but we know that it's content. In other words, it's any type of content. And this is where existentials come into place. You lose type relationships because the compiler can't predict anymore. So if there's something specific to image content, the compiler doesn't know anymore, but you will still be able to benefit from all this generic code that you write using existentials. So there is like a break-even point, you could say. So I remember from the WWDC session, they showed kind of like visuals with a box, and then something goes out of the box, and you know, it made it easier to understand for some, but I kind of like wanted to have a better understanding with alternatives written in code. So I want to show you a few. You could basically say that box example that I just mentioned, and you can write it in code like this, but you still have an inner value with any content. So we're still using existentials. So it's not entirely how you would write this before. This, though, is type erasure that I did use before. You kind of create a container, you initialize it with another type, and you erase the relationship with the actual type. But there's a new any content that we can now start using everywhere. So the favorite method that we just had in Swift 5.6, we could have rewritten it using any content this way. But with the new existentials, it looks much nicer, and we don't have this overhead code to write. So in any case, we have any value conforms to content. And I want to go back a little to the performance that I mentioned earlier. So here, we define a property as any content. And that also means that even though we started with image content, we can still change it to video content. So it's much more dynamic. And that also means that's harder to predict for the compiler and perform optimizations accordingly. With opaque types, the type is the same for the scope of the value. So the compiler knows that it will always be image content in this case, and we can't change it to video content because the requirement is that it has to be image content. So in summary, any protocol stands as any value conforming to protocol. Swift 5.7 adds support for self or associated type arguments. It's basically the error that I showed that kind of like feels like a restriction that is now removed. This is an interesting one. In Swift 6, you will be required to explicitly mention any. And the reason is that the Swift team wants you to know that you're opting in for that extra performance hit. So you should consider rewriting it to opaque types or something that's more predictable for the compiler. How big is the performance hit, you can say? It's probably, for most apps, too small to say, like, okay, I'm going to optimize all this code. But, it's something to be aware of. And also something to look at, because in my experience, Xcode recommends using any, while in many cases you could use some as well. And I'll show that in an example later. Since it's unpredictable, performance hits. For those that watched carefully during WWDC, this looks very much like one of those slides that were in the session. But this time I actually show code examples with it to compare some to any. And it shows that with some content, the type for the scope of the value is the same. And I'm repeating this a lot because that it hopefully will click. And with existentials, we can use any type, but we lose the relationship. So in the left example, you can say it's all image content. And when you deal with some content, in this case, you actually get the relationships from image content. And in the second one, with any content, you'll deal with just the protocol content. Hopefully that makes sense. I'm using Twitter a lot. I'm not sure if I'm doing that in a few months still, but this was one of the trending topics at the time. And you saw that image popping up everywhere. And Ben makes a good point that from the implementation side, it looks like you're using the same thing, but it's actually something different underneath if you look at existentials and opaque types. I found it funny and quite related to this talk, but I want to take you to some practical examples with all the things that we just learned. First of all, we have this print method. And if you look at this code, we can say T conforms to protocol. And we have a shorthand for that. So we can rewrite this and using some. I actually went through the code base today as a coincidence for WeTransfer and found quite some places where I could apply this change. It's quite an easy change, if you will. Up next, if you're developing SDKs that are used publicly, maybe you have an open source library, or maybe your company is actually developing a library, it's pretty important to think about what you make public and what not. And in this case, we have a remote image fetcher, which is defined as public, which means that if we happen to rename remote image fetcher to a different name, all the implementers are required to rename as well. it becomes a breaking change. You need to major bump your version. It's not ideal. So let's see if we can rewrite this. So we introduce a new protocol, image fetching. And with that, we can actually already apply this change. You can see that the remote image fetcher now becomes non-public, and implementers of the SDK only have to deal with an image fetching protocol. This works great, but as soon as we start introducing an associated type, we run into issues. And it makes sense to introduce this associated type image because we might have a UI image or an NS image, right? If your SDK becomes multi-platform. So we need to solve this, and this is a place where Xcode would recommend you to use any. Now, this could be true, right? Like, it might be an existential, but it all has to do with the scope of the method. Is the value consistent or not? So by now, we can't really tell because we don't see the inner body. So let's have a look. In this case, the value inside the scope of the method is not consistent. We either have a local image fetcher or we have a remote image fetcher, so it makes sense to use any in this case. However, if we were to always return a remote image fetcher, the type of the value is consistent inside the scope of the method, so we can define some, benefit from performance improvements, and keep the type relationships. Say we want to introduce a nice extension as well, where we can use that image fetcher to quickly configure an image to an image view. In this case, we can't assign image because we don't know what it is. Do we know that it's an NS image or a UI image? This code doesn't work right now. This is another feature that was introduced, and these are constrained existential types, and it's using the primary associated type. I'm using a lot of names. You can look up the proposals later on, where it will be explained in more depth. But what it will allow us to do by defining a primary associated type image here, we can actually add constraints to the existential type as well. So in this case, we say any image fetching as long as the associated value is of the type UI image. And now the compiler can predict and allows us to set the image accordingly using the generic image fetcher that we defined. For those that are very sharp here, we could actually rewrite this and using opaque types and use constrained opaque types. And now I'm in need of a coffee as well. No worries. So I was wondering what would be questions you might have after seeing this talk, and I figured this would be one of them. And if I pronounce this, it sounds exactly the same, but there's a difference between any view and any view. Lowercase or uppercase, either way. I never really used any view either way. The first one, that one. So I don't think you need it at all. But this was actually answered in the WWDC Slack, which is full of super interesting questions that you can still look up. There's some articles that copied over all the interesting questions. And this was one of them. And in most of the cases, you should be able to solve this using View Builder or existential any. So I don't think, let's say if you still use any view, see if you can rewrite it, because I'm pretty sure there should be ways to do that. Another one, does any relate to any or any object? For that, I want to recommend reading my article. I went into depth there. Short answer, no, but there's more in-depth answer to it if you're interested. So, wrapping up, and I want to give you some summary guidance, so to say. Try to start with some, if the generic parameter is only used in one place. If you're not sure about is it used in one place, try to use some, and you will quickly notice because the compiler won't be happy. But yeah, if you can use some, that would be great because I think readability improves. Change some to any when you have like arbitrary types or more random values, like we saw with the array where it's not only image content, but also potentially video content or any kind of content. And lastly, you can still use generics as the final solution. It's still available. This is just another option in our toolbox. Who's still feeling overwhelmed? I can imagine, like it's quite a lot. And like I said before, don't see this as something you now must use everywhere. I tried to use it in the WeTransfer code base, and I found it pretty hard as well myself. I'm still learning. It was actually pretty hard to wrap my head around this myself for this talk, and I'm still learning. But yeah, take it step by step, take it easy. You're at least familiar with this concept now. You know that it exists. And use that to see if you can actually apply it. The benefit of me preparing a talk is that I prepare it by writing articles. So there's an article on opaque types, existential, all the generic stuff that I discussed. So you can look up those articles and read it up on your own speed. Briefly mention of some of the other things that I write and do. We have Swiftly the articles, a newsletter. If you don't follow it yet, it can be a great way to not miss any Swiftly articles or any articles from the community. Or if the Swift Studio ever comes live, maybe I can post that in my newsletter. And Swiftly Jobs, it's a new version. If you know the old version, this one is much better. You can actually upload your own profile as well and get in touch with interesting companies. Maybe it's something for you. I did this talk in Frankfurt, which made a lot more sense to show this. I'm not sure if it makes much sense for you, but this is about investing in stocks and such. It's a side project that I have. Maybe you find it interesting. Come to me and I'll show you the test flight link again. But this one, who uses Rocket Sim? Only one hand? I always hope to see 0 hands because that means 30 new users, But nevertheless, Rocket Sim is a simulator enhancing tool. It allows you to create recordings with bezels, with touches, convert it into Giphy, but as well, all the folders, delete derived data really quickly, reset permissions, super handy if you're working on push notifications and all those kind of things.
Cleaning derived data.
Yeah, exactly. That's what I mean. As well as showing a grid on top of the simulator or using rulers to align objects or compare design on top. Well, all kinds of features. Check it out. If you are a fan of Rocket Sim, I have some pins with me. If you're not a fan and you want to become a fan, you can still get a pin. It's fine. With that, I want to thank you for your attention and hopefully you learned something today.
I'll just switch on the audience mic.
Yes.
I'm assuming that there is a question segment right now.
Questions are the hardest part of giving talks, You can't prepare that.
I have a question. I feel overwhelmed.
Yep.
I want this, how this generics works right now.
Yep.
And do you think that we should more use composition than generics? Or generics are the good way?
It's very much a choice, I would say. And there's many aspects to that choice, right? If you decide to use generics because you're convenient with it, but you're working with a team of 10 developers, you're kind of pushing them to learn generics as well or deal with generics. And I'll be honest, composition is probably much easier to manage. I rewrote a lot of code in generics and ended up rewriting it again because I eventually got stuck, right? So if you look at the image fetching example, I like the generic solution in the end very much, but it might be pretty hard to get to that place. So I would say pick a solution that's convenient for you, but definitely try to challenge yourself to write it using generics and maybe use it like a timer, right? Say to yourself, okay, I tried generics, but I only spent an hour on it. And if it's not finished within that hour, I'll stick with composition because I'm familiar with that. That would be my suggestion.
I didn't follow if anything changed in that regard. So the performance of the generics across the border of the module is bad because it happens in runtime as not specialized.
Yeah.
Did anything change in that regard? Because if you have an app that is modularized, that would affect your performance.
Yeah, so I think this is the general answer, right? If you use existentials over opaque types in terms of performance, right? So you kind of move the performance hit to runtime because it's dynamic and the heap memory can't be predicted as much as you can with opaque types. And I'm not entirely sure because you mentioned packages, and I see you're still confused or not giving. I'm giving not the answer that you need.
No, There used to be the case that the standard library, they use the generics a lot.
Yeah.
They have this underscore specialized, and actually not even that. There's a special pass on compilation that specialize the type. Did anything change in that regard for the non-standard library, for the regular modules?
I'm not sure if anything changed there. That's the honest answer. Because I'm not familiar with it as well as much as I wish I was for answering this question. But you saw the PR that I mentioned, quite a lot changed in terms of generics. And I believe the build time improvements of this year were mostly related to that as well, because the compiler can much better predict how generics should be used. So I'm unable to give you the exact answer, but it could very well be that something changed there because a lot happened in that area. Could be interesting to look that up and see on the Swift forums or anything. Any more questions?
You skipped one thing.
Oh.
Which is extensions to the protocols. And there's a limitation there with the self. Do you have any comment on that? When you use a self in a function that is, the extension to the protocol, the default implementation, there's like a limitation. You cannot use that, and there's a very bad workaround with that. Are you familiar with that?
I'm not sure. If you use like self, the word self.
Yeah, in constraints.
Yeah. So one thing that currently applies is like the reason it's also called Swift 5.7 and we got Swift 5.8 and not Swift 6 is because they're still on that roadmap to make the final end of the roadmap to Swift 6, right? So a few things that they already have working but didn't activate are kind of still being worked on. So this is more a generic story I want to share is that we're not there yet, and this is very much one of the first iterations I believe on existentials and opaque types and such, and it will improve over the upcoming versions. Probably I have seen this, but I'm not sure which limitation it is. But at least I don't have an answer to it. You have good questions, I guess. But show it afterwards. I'm keen to see it.
There was a question on the chat.
I was
really technical.
I was curious, actually. Yeah.
Whether you could repeat questions, but yeah, and I think that this discussion would be not so easy to. Well, actually, I have a question.
Yeah.
Because when I tried to play with it when Xcode 14 beta came out.
Yeah.
I thought that this Swift features would have much more impact that it eventually had for me. Have like
similar experience. Yeah. So like I said, actually today I started looking through the whole code base and see where I can apply this new changes. And at least to me, the error that I showed earlier was something I run into every now and then as a limitation. And at that point I was like, God damn it, but it only happens now and then, right? Like, how often do you really write generic code or reusable code in such way that you go to the limitations of Swift? So I kind of have the same feeling if you describe it this way, right? You have the idea this has such a huge impact, especially in the WWDC session. They were like, poof, and it's gone. That error, that's literally what he did. So you were like, oh, damn it, this is great. This opens up doors. But yeah, no, it doesn't have such an impact on the retransfer code base either. But I also feel like it's harder in retrospect to rewrite code than it is to when you actually write a solution from scratch, where you naturally write code, you expect it to work, and you now no longer have the limitations that you had before. I'm not sure if that makes sense, but it's like a different angle of approach, which has an impact, I think.
Yeah, because I felt like I had a protocol associated type that also conforms to protocol.
Yeah.
And I thought that I would be able to make it more readable somehow.
Yeah.
And not have all this where.
Yeah.
Stuff, etc. But it didn't.
Yeah. There's only a few places where you can do that, and I think if it's the generic is only used as a parameter, it should always be possible to do it. But as soon as you start to reuse that same constraint in different places, or another limitation I saw is if you use a generic dot type, because you want to use like static methods or something, you can't define that as an opaque type. So it has to be an actual instance, if that makes sense. So there's still a few limitations that I totally believe will be removed in the future, but for now, yeah. Okay. Well, if there's any other questions as well for the chat, feel free to always post me a message on Twitter. I'm not on Mastodon yet, but I still hope we will survive. But nevertheless, for those here, we can also discuss anything that you want. So thanks a lot. Now I can drink a beer as well,